Alright, this is Unit 7, Lesson 3 on Arithmetic Sequences. For the first problem, I'd actually like to find a formula for the nth term of the sequence, given that the 7th term is 15 and the 19th term is 33. Now we know for an arithmetic sequence, a sub n is equal to a sub 1 plus n minus 1 times the common difference d. I can actually write an expression like this for each of these two terms. I can write 15 equals a sub 1 plus 15 was the 7th term, so n is 7 minus 1 times the common difference. I'll simplify that equation a bit here and say that it's 15 equals a sub 1 plus 6d. Now I can also do the same thing for the 19th term, which is 33. 33 equals a sub 1 plus 19th term minus 1 times the common difference d. Again, I'll simplify 33 equals a sub 1 plus 18d. Now, the reason why I did that is I actually want to find the first term and the common difference so that I can write my general expression for the nth term. So I'm looking for a sub 1 and for d here. Now with these two equations, I can actually subtract them. And that will allow me to cancel out the a sub 1s. 15 minus 33 is negative 18. Those cancel. 6d minus 18d is negative 12d. Now I can just solve for d, divide both sides by negative 12, and I'll get that d is 1.5. So that is the common difference for this arithmetic sequence. Now I still need to find the first term, a sub 1. So I can take that 1.5, plug it back in for a sub 1 in either of these two equations. I could say, for instance, 15 is equal to a sub 1 plus 6 times the common difference is 1.5. 15 equals a sub 1 plus 9, and so a sub 1 is equal to 15 minus 9 is 6. The first term of the sequence is 6. So now the expression for the nth term is a sub n equals the first term 6 plus n minus 1 times that common difference of 1.5. Now it's actually okay just to leave your expression in this format, but if you wanted to clean this up a little bit, you could distribute the 1.5 through the parentheses. You would get a sub n equals 6 plus 1.5 n minus 1.5. And if I combine my like terms here, I get a sub n equals 1.5 n plus 4.5. So either that equation or that equation are fine as answers here. Now that was more or less an algebraic approach. You could also sort of do this with common sense. Same problem. Think about it like this. 15 is the 7th term, that is a sub 7. If I wanted the 8th term, a sub 8, I would just add that common difference d, and that would give me that 8th term. Now I don't know what that common difference is, or at least I'm going to pretend like I don't. And if I wanted the 9th term, I could add that common difference again. And if I wanted the 10th term, I could add it again, and so on and so forth. Well, if I want to get to the 19th term, which I know is 33, the question is, how many times do I have to add d to 15 to get to 33? Well, the answer is just simply, if 15 is the 7th term and 33 is the 19th term, well, that's a separation of 12 terms. So I would have to add d 12 times. I could then say this, that if I start with 15 and add my common difference d 12 times, I should get to 33. With that simple equation, I can just solve by subtracting 15 on both sides. 12d equals 18. Divide both sides by 12. d is 1.5, and that is the same value for d we found just a moment ago. Now to find the first term, a sub 1, I could do sort of a similar equation. I could say that if I start with the first term, I would have to add my common difference a certain number of times to get to this guy right here, to get to the 7th term. Well, I would actually have to add that common difference from the first term to the 7th term. I would have to add that common difference 6 times to get to that 7th term. So the first term plus my common difference is 1.5. I'll add it 6 times, and that should get me to that 15. Now I just have to solve for a sub 1. a sub 1 plus 1.5 times 6 is 9 equals 15. Subtract 9 on both sides, and we get a sub 1 equals 6. My first term is 6. And so again, I get the expression a sub n equals 6 plus n minus 1 times 1.5. Now I would like to do one more problem here. For this problem, the first term of an arithmetic sequence is 510. The last term is negative 358. Now right there we can tell that this is an arithmetic sequence that is decreasing, since the last term is less than the first term. We're also given the common difference is negative 14. That's also a clue that it's decreasing. Our common difference is negative. The question is, how many terms are in that sequence? How many terms would it be from 510 to negative 358? Well, we can again use our formula a sub n equals a sub 1 plus the quantity n minus 1 times that common difference d. For a sub n, I'll put in the last term that I'm given. Negative 358 is the last term of the sequence. The first term is 510. I do not know what n is, that's what I'm trying to find. And the common difference is negative 14. Now I really just need to solve that equation for n. I would start by subtracting 510 on both sides. And negative 358 minus 510 is negative 868. And I'm left over here with the quantity n minus 1 times that negative 14. Now I could distribute the negative 14 through the parentheses, but it's actually easier at this step just to divide by negative 14 on both sides. And that will cancel out the negative 14 on this side. Negative 868 divided by negative 14 is 62. 62 equals n minus 1. Just add 1 on both sides. 63 is n. So negative 358 would be the 63rd term of this sequence.